Alright, sorry for the little interruption. Before the video ended, I was talking about we have seen how to factor out trinomials when the coefficient of the first term is 1. Now let's see how to factor out when the coefficient of this first term is different from 1. So when to factor when the coefficient of a is different from 1. For example, I will take an example. We have 5x squared plus 5x squared plus 14x minus 3 plus 14x minus 3. So now we discover that our a is different from 1. In the previous example, we could tell that a was equal to 1. So if I look at it critically, I just need to compare this expression with my general form, which says my a, let me use a different ink, which says a is equal to 5, b is equal to 14, and c is equal to minus 3. Alright? Now, we can forget about the negative sign for now and just focus on the constant term. But when we are multiplying, or you can put the negative sign, it's okay. But when we are multiplying, we have to take into consideration this negative sign. Now, I will say we are going to use the same method. We need two factors. When we multiply, it gives us the middle term. When we multiply, it gives us the constant term, and when we add, it gives us the middle term. Of course, our D and E means these two factors. So AC will give us what? AC gives us 5 times minus 3, which is minus 15. And we need to find that sum. That sum is A plus C to give us 14. So now we need to find out the factors of 15. Now, we can forget about the sign at this level and find out just the factors of 15. So if I find out the factors of 15, I am going to have 1, 3, 5, 15 itself. Alright? So we have minus 1, minus 3, minus 5, and minus 15. Now, we need two numbers. When we multiply, it gives us minus 15. This is where the sign comes in. We need two numbers. When we multiply, it gives us minus 15. And when we add, it gives us plus 14. If I look at these two numbers very well, if I take 3 and 5, yes, 3 and 5 gives us 15. But they don't add up to give us 14. If I take a minus 3 and minus 5, gives us plus 15. But we need negative 15. If I take 1 and 15 itself, it gives us plus 15, but we need negative 15. So at the end of the day, I discovered that I need plus 1, I need a 15 and a minus 1. 15 and minus 1. 15 times minus 1 gives me minus 15, but if I add 15 and a 1, I have positive 14. So I come back to my expression, I simply write my 5x to the power 2 plus, I have now 15x minus 1x is the same as x. We simply write our x and minus 3. Again, we go by grouping. We can group this 2, we can group this term. So if I group this, I discover that 5 is common between itself and 15, which gives us 5. And again, x is common. We can still factor out x. So what is left in the bracket is x plus 3. Now, if you look at again here, I can decide to do a bracket here, which gives us just my x minus 3, and the coefficient of this bracket is minus 1. The coefficient of this bracket is minus 1. So therefore, I can still maintain that bracket to have minus 1 bracket x minus 3. So again, when I look at this expression, I discover that now here, once the negative is factored out, it automatically affects the inner bracket. Remember I told you that? Because when we open the bracket, we should get the same sign as that original bracket. So here it becomes plus. Automatically it becomes plus, because if I multiply minus 1 times plus 3, I should get minus 3. Alright, so this becomes x plus 3 brackets 5x minus 1. Remember we said we can only factor out things that are alike. they must be like terms that we can factor out. We cannot factor out unlike terms. So this becomes our final answer. So the procedure applies same for when the coefficient of the first term in the trinomial is 1 and when the coefficient of the first term in the trinomial is different from 1. Now let's look at another example. Let's look at another example when the coefficient of the first term in the trinomial is different from 1. We have 4z squared plus 19z. We have 4z squared plus 19z. 4z squared plus 19z plus 12. Plus 12. 4z squared plus 19z plus 12. So we can always take bigger numbers. All you just need to do is to find the factors and find those two numbers which can be added and multiplied. So again, our A here is A is equal to 4, B is equal to 19, and C is equal to 12. Again, our product is AC, or we can take DE depending on you. So you should know that the product should give you A times C should give us